Hello grade 11 students. Your favorite maths teacher is here today with another popular mathematician. Who's that? Pythagoras or Pythagoras. The correct term is Pythagoras because one of my Greek students told the correct pronunciation is Pythagoras. But British people use Pythagoras. We are influenced in British way. So I'll call Pythagoras Theorem. So every day you need Pythagoras theorem. Even the carpenter needs Pythagoras theorem for making chairs. So he needs 90-degree angles. Masons look at 90-degree angles in foundations, walls. So without knowing, every day we are using Pythagoras theorem. So basically, Pythagoras theorem is related to right angle triangles. So what is right angle triangle means? One angle should be a 90-degree angle. So we'll see how we can apply Pythagoras theorem in real life applications. Now look at this triangle, ABC triangle. So here marked right angle. So before we start Pythagoras theorem, we need to identify the sides. So we call opposite to 90-degree angle. The side AC is the hypotenuse. And the other two sides we just call two sides. Hypotenuse you have to identify, the other two sides. So what is hypotenuse here? AC. Other two sides AB and BC. What's the right angle? B angle is the right angle. Look at this triangle, PQR triangle. Which angle is 90 degrees? P angle is 90 degrees. So what's the hypotenuse? Opposite to right angle, QR is the hypotenuse. Then what are the other two sides? Other two sides, PR and PQ. Look at this triangle. It's also right angle triangle. Which angle is 90? M angle is 90. Then what's the hypotenuse? KL is the hypotenuse. Then what are the other two sides? Other sides are KM and ML. Look at carefully. Without the diagram, you can write down the other two sides and the hypotenuse. Now look at B angle. Here for the hypotenuse, B letter is not there. For the two sides, starting from here, AB, BC. Look at this one, P angle is 90. Then what's the other side? QR without the P letter. Then what are the other two sides? QP or PQ and PR. You can connect with the hypotenuse. M is 90 degrees. Then without M letter, the other two letters comes in the hypotenuse, and for the other sides, M comes. Now we'll see without the diagram. Write down hypotenuse. What's the hypotenuse here? without y letter. X, z. What are the other two sides? xy and yz. You can connect y letter with the hypotenuse. D if is a triangle, D angle is 90. So what's the hypotenuse there? Hypotenuse is without D, EF. Then what are the other two sides? Other two sides are ED and DF. So you should be able to identify the 90-degree angle, what's the hypotenuse and other two sides. Now, again you need to know how to expand brackets. So we'll take some examples and see whether you can remember this. A plus B whole thing square. So what's the easiest way to do? Square the first term, double of first and last, 2 times A and B multiplication plus 2AB and then last term squared. You get 3 terms. Don't forget that, because most of the students I have seen just writing A squared plus B squared. That's wrong. You are getting middle term as well. What's this one? Square of the first term, square of the last term comes here. Always positive. Then the middle term becomes the 2 times the product of these two, minus 2xy. This one, two sides BC and CD. You can do the same thing. BC squared, CD squared comes over there. Then what's the middle term? Double of these two, plus 2BC and CD. Now try this one. What's the first term? AB squared. What's the last term? BC squared. What's the middle term? Minus doubled AB into BC. Now let's take this one. AB is given, CD over 2. When you square it, what happens? When you square it, you need to square other side as well. The whole thing squared. So what is that? You can write down CD squared over 4. 2 squared becomes 4. If xy equals AB over 2, what's xy squared? When you square both sides, you get AB squared over 4. 2 into 2, 4. So remember, when you have an expression, when you want to get the square term, square both sides. Now take this one. PQ is 2CD. When you want PQ squared, how you do? 2CD whole thing squared. So 2 times 2, 4 CD squared. When it's 3CD, same thing, you need to square the whole thing. When you square the whole thing, 3 times 3 comes. 3 times 3 is 9 CD squared. This one, square both sides. What happens here? You have to square this term as well as this one. So you get 2 into 2, 4. 4xy squared is equal to 3 into 3, 9mn squared. What about this one? 5xy equals 3pq. Square both sides. You get 25xy squared and 9pq squared. So you need this one when you apply Pythagoras theorem. Now look at these diagrams and find area. This is a right angle triangle. What's the area? Half times base times perpendicular height, half BA or half AB. This one, two sides are x and y. Area is half times, base is x, perpendicular height is y, half xy. This is a square. What's the area of a square? Area of a square is x into x, or you can write x squared because the side is given as x. What's the other shape? Trapezium. How you find out the area of the trapezium? Add the two parallel lines, a plus b, divide by 2 and multiply by the perpendicular height, h. What about this one? This is also a trapezium. These are the two parallel sides. So what's the area? Area equals half. What are the two sides? B plus C is the sum of the parallel lines. What's the perpendicular height? B plus C. B plus C into B plus C, you can write B plus C squared. Look at this one and we'll try to find out. When you take AB, what's the square on AB side? So if you draw a square on AB side, you get same length as this. So what's the square? Area of the square on AB side. Area of the square on AB side. You get AB into AB, AB squared. What's the area of the square on BC side? Area of the square on BC side. What's the area? So when you have to draw a square here. BC into BC. So that's BC squared. So likewise, what's if I draw a square on AC side? What's this area? Area of the square on AC side? I get AC squared. AC into AC. Again, we'll take the triangle. If I want the square on AB side, what's the square on AB side? The area of the square on AB side, that's AB squared. Then what's the area on BC side? Area of the square. Area of the square on BC side. Then that becomes, you get a square here, BC into BC, BC squared. Then what's the area of the square on AC side? That's AC squared. So you need to know the area of a square on all sides. Now we'll try to see what's Pythagoras theorem is. Now for that I'm doing a small activity. So we'll take a triangle with side length 3 and 4. I'll take side length 3 1, 2, 3, 4. 4 and 3. So what's the triangle? Here I get this triangle. 4 squares here, 3 squares up. Then I want to get the square on all sides. So I'm taking this one as A, B, C. This is 90-degree angle. So this is 4 squares, 3 squares. So what's the area on BC side? I'm getting 1, 2, 3, 4. So here I'm getting a square 4 by 4. And here what's the area on AB? This is 3 length. So I'm getting 3 by 3 square. I'm getting 3 by 3 square. So here I'll try to color that. This is 3 by 3 and this is 4 by 4. So what's the value? So this is 9, I'm getting 9. This is how many squares? I'm getting 4 by 4, 16 as the area. Now it's difficult to draw a square there. We can't measure properly. So what I do, I am doing this trick to draw the square on AC side. So I'm taking, this is 4. So I'm taking 3 squares here. 1. I'm taking 3 squares here. 1, 2, 3 and 4 up. 1, 2, 3, 4. And draw this line. Here what I do, here 3 there, I'm going 4 squares up. I'm going 4 squares up. 1, 2, 3, 4 and 3 squares here. Then connect here to here. Again I'm doing 4 squares to the right and 3 squares down. Here to here. Then I connect. I want to see what's the area is. I can show you this is a square with one side AC. How can we show that? Now take, this is 90 degrees and this is alpha and this is beta. So 90 alpha beta total is 180. So this is 90 is there, so alpha plus beta is 90 degrees. So if this is alpha, now look at this is 4 and 3 triangle. So 3 and 4 same triangle, other way around. So what is alpha? So this is 90 degrees. So what is alpha? Alpha now along this side 4 side. So alpha is here. Then definitely this should be beta. Here this triangle also same thing, 3 by 4. 3 side and 4 side. Where's alpha? Alpha is here, beta is here and this is 90 degrees. This way also same angle. So this is alpha, this is beta and this is 90. Now look at this one. Alpha beta is there on this point. So what should be this angle? This is a straight angle. This should be 90 degrees. Here alpha beta is there. So this should be 90 degrees. Alpha beta is there. This is 90 degrees. alpha beta, this is 90 degrees. So I drew a square with AC side. Now I want to check what's the area of this one. To do that, I can take the whole picture, this whole square, and get the area, subtract all the 4 areas of triangles. So I'll do that and see whether I'm getting a certain answer related to this one. Okay, we'll do it. How many squares this way? 1, 2, 3, 4, 5, 6, 7. 7 by 7 square. So what's the area? 7 by 7, 49. Then what's the area of this one? One triangle is half times, one length is 4, other one is 3. So 2 times 2, 2 times 3, 6. One triangle is 6. So this is 6, this is 6, 6, 6. So 6 times 4, 24. Then the whole thing is 49. 49 minus 24. What's the area here? 49 minus 24. You get 25 here. Now, do you get any relationship between these 3 numbers? This is 9, 16, 25. What do you think? 9 plus 16 is 25. So this plus this is equal to this. So we get a relationship. 9 plus 16 is equal to 25. So Pythagoras found the relationship like this. When you take a triangle, right angle triangle, the 2 sides are these 2 and this is the hypotenuse. So this is the square along the hypotenuse. Square along the hypotenuse, these are the other 2 sides. So he found out a connection between the areas you are getting with the squares. So we'll see what Pythagoras mentioned about the theorem. In a right angle triangle, the area of the square drawn on the hypotenuse. So if you take this triangle, this is the hypotenuse. I'll label ABC triangle. AC is the hypotenuse. So in the right angle triangle, the area of the square drawn on the hypotenuse, this area is equal to the sum of the areas of the squares drawn on the remaining sides of the triangle, which include the right angle. So that's what we found here. These are the 2 sides. This is the hypotenuse. So the area of the square formed on the hypotenuse is equal to the sum of areas of the squares on the other 2 sides. That's what the Pythagoras theorem is. So we'll try to prove with different ways. So I'll take this diagram and try to prove the Pythagoras theorem. According to Pythagoras theorem, so this is B angle is 90 and this is the hypotenuse. So he mentioned A squared is equal to area means A into A. What is this one? B squared plus C squared. Now we'll try to prove that using this diagram. So what I did, I took the other length here. To this triangle, I added, if this is C, I added B length and C length here. And then this way, you get hypotenuse there. So what is the full shape you are getting? ABC, D, E. So what is ABCE diagram? ABCE is a trapezium you are getting. In the trapezium, we'll try to find out area separately and add it to get the area of the trapezium. So what's the ABC triangle area? Half BC plus, what's this triangle? ACE triangle? Half A times A. What's CDE triangle? Half B into C. So what's that? Half BC, half BC. You get BC plus half A square. Now if you are taking the trapezium, the whole trapezium, these two sides are parallel. So what's the area of the trapezium? When you use the formula straight away, ABCE trapezium, B plus C divide by 2, B plus C divide by 2, and then multiplied by the perpendicular length, B plus C. B plus C into B plus C, I can write B plus C whole thing squared over 2. Now expand brackets. What's the easiest way to expand? Square the first term, square the last term, and you are getting the middle term as double of these two, BC. So what you are getting here? When you divide, you get B squared plus C squared divided by 2 plus 2 get cancelled out, BC. Now we know these two are equal. So this is first one, this is second one. 1 and 2 equal. So I can write BC plus half A squared is equal to B squared plus C squared over 2 plus BC. BC get cancelled out. Multiply by 2, the whole equation. Multiply by 2, you get A squared is equal to B squared plus C squared. So what we need here? So that's the Pythagoras theorem. Now we'll take another diagram and see. Now this time, this is the ABC triangle. So here what you need to prove? A squared is equal to B squared plus C squared. Now I'm taking, if this is C, this way B. Other way around C, B. C, B. I created a square like this. So what's the area of the whole thing? This is B plus C, B plus C. So the area of the whole square is B plus C squared. B plus C into B plus C. So when you expand that, I get B squared, C squared, and the middle term 2BC. If I take separately 4 triangles and the square, what's the area? I can do the same thing. Area of square what's the triangle area? Half BC. Half BC, half BC. How many triangles? You get 1, 2, 3, 4 triangles plus area of the square. A into A, you get A square. So when you simplify, you get 2BC plus a square. Now both are equal, equate 1 and 2. What you get? 1 equals 2. You get b squared plus 2bc plus c squared is equal to 2bc plus a squared. 2bc, 2bc get cancelled out. So what you get? b squared plus c squared is a squared. So same thing there. So this is another way of showing the Pythagoras theorem. Now we'll take the form of proof. So take the ABC triangle and data is, we know this angle is 90 and we need to prove that this is the hypotenuse. BC squared is equal to AB squared plus AC squared. We are doing a construction here. AD is a perpendicular line. Now we'll try to do the proof. We'll take ADC triangle and ABC triangle. What can you say about those two triangles? ADC. I'll put alpha here and beta here. So alpha plus beta plus 90 is 180. So same thing here. This is 90. So alpha plus beta should be 90 because 90 there. So if this is beta, what should be this angle? This is alpha. If this is alpha, this is beta. So we'll try to find out the angles in ADC angle. We know D angle is equal to A angle, that's 90-degree angle given. Then if you take this angle, C angle, that's alpha angle is equal to C angle in the other triangle. Beta angle is A angle in the ADC triangle. What's that? Beta equals to B angle in the big triangle. That's beta. So we know these three angles are equal. So these two triangles are equiangular. So if these two triangles are equiangular, these are similar triangles. So we can write down the corresponding ratios. So the corresponding ratios are equal. So corresponding ratios will take opposite to 90-degree angle BC. Then opposite to 90-degree angle is AC. There is equal to. We'll take opposite to beta side. That's CD. Opposite to beta side for the bigger one, that's AC. And here beta side for this one is CD. So this is my first equation. Then I am taking other two triangles, the other one and the big one. ABD triangle and ABD triangle and ABC triangle. So similarly, I can show that these two are equiangular because A angle is 90 degrees. That's equal to D angle in this triangle. Then alpha angle here, that's A angle, and this is C angle, that's alpha. Beta angle is B angle for ABC triangle, and the other angle also B angle. So here also equiangular triangles. Then these are similar triangles, so the corresponding ratios are equal. What are the corresponding sides there? If you take Opposite to 90, that's BC. Opposite to 90 here, that's AB. Opposite to alpha, that's BD in the smaller one. Opposite to alpha, that's AB. Now we'll take this one and this one as 2. Look at the two ratios. From the first equation, I want to cross multiply and write down AC into AC as AC squared is equal to BC into CD. From this equation also I want to cross multiply. AB squared is equal to BC into BD. I'll add these two, AB squared plus AC squared, because we need AB squared plus AC squared. When you add these two, what happens? AB squared plus AC squared. You get BC BD plus BC CD. BC is common, take it out. BD plus CD or DC. What's BD plus DC? This plus this is BC. Instead of this one, I can write BC. So BC into BC, you get BC squared. So according to Pythagoras theorem, BC squared is equal to AB squared plus AC squared. Now we'll try to write down the relationship between Pythagoras theorem with these sides. This is a right angle triangle, so you can apply Pythagoras theorem. What's the hypotenuse? A, opposite to 90. So we can write square of the hypotenuse is equal to the sum of squares of the other sides. B squared plus C squared. When you take this triangle, how can we write down the relationship? We can write AC squared is the hypotenuse squared. What are the other two sides? AB squared plus BC squared. Now look at the other triangle. Which one is the hypotenuse? Opposite to 90 degrees, QR. So I can write QR squared is equal to PQ squared plus PR squared. If I want the other side, if I want PR, how can I write PR squared? PR squared is QR squared minus. So always hypotenuse squared is first and then you can subtract the other side. So QR squared minus, you want PR, so PQR. If I want the other side, PQR, how can I write? PQR, PQ squared. PQ squared is equal to QR squared minus PR squared. If I want in this triangle AB squared, how can I write? AB squared is AC squared minus BC squared. Now take element triangle and write down what is KL squared. KL squared is not the hypotenuse, so KM squared minus LM squared. So what is Km squared? Km squared is the hypotenuse, so you can add KL squared plus LM squared. So remember, if you want the hypotenuse side, you can add the other two sides. If you want another side without the hypotenuse, you have to subtract from the square term of the hypotenuse. So find unknown lengths. Look at this triangle. So hypotenuse is A. So I can write a squared is equal to 3 squared plus 4 squared. What is 3 squared? 9. 4 squared is 16. 16 plus 9, 25. So how can we find out a square root of 25? Plus or minus 5, but we take plus 5 because this is a length. So 5 centimeters. Do this one. B is not the hypotenuse. So what can we write? B squared is equal to 10 squared minus 6 squared. 10 squared is 100. 100 minus 36, you get 64. Square root of 64, you get 8. 8 centimeters. So remember these measurements. 3, 4, you get 5 here. 6, 10, and this is 8. Now look at this one. C is not the hypotenuse, so how can you write down? C squared is equal to 15 squared. 15 squared minus 12 squared. So what is 15 squared? 225. 12 squared, 144. So when you subtract, what you get? You get 169. Square root of 169 is 13. So that's 13 centimeters. 12, 13 and 15. This one, D is the hypotenuse now. So how can you write down? D squared is equal to 5 squared plus 12 squared. 5 squared is 25. 12 squared 144. You get 169. Square root of 169 is 13 centimeters. So 5, 12, 13. This one, E is not the hypotenuse, so you can write E squared is 26 squared minus 24 squared. So what is 26 squared? 276. We'll check it. 26 into 26. 676. 676 minus 24 times 24. 20 and 4. 2 times 4, 8. 2 times 2, 4. 4 times 4, 16. 4 times 2, 8 plus 1, 9. So you get 576. So you get 100 there. Square root of 100 is 10. So you get 10 centimeters for E letter. And this one, F. So you need F squared is equal to 39 squared minus 36 squared. Here you can use difference between two square terms. I can write 39 plus 36, 39 minus 36. It's easy when you use the difference between two square terms. 9 plus 6, 15, 1 remaining 7. 75 times 3. What's 75 times 3? 225. Square root of 225 is 15 centimeters. So square root of 225 is 15 centimeters. So this is 15 centimeters. So look at these numbers we got. 3, 4, 5, 6, 8, 10, 12, 13, 15, 5, 12, 13. We'll find out what are these. We call that these are Pythagorean triplets. So we found out 3, 4, 5 is a triplet. 3, 4 one side and the hypotenuse is 5. Then we found out here, can you remember from the previous page? 5, 12, 13. 5, 12, 13. So we can find out any triplet this way as well as this way. So here 3, 4, 5. And then we found out 6, 8, 10. So what's that? 6, 8, 10. Multiply this by 2. What's the other one? 10, 24, 26. We got that one. So here, when you multiplied this by 2, you can get 6, 8, 10. Multiply by 3, 3 times 3, 9. 3 times 4, 12. 3 times 5, 15. That's also a triplet. So this way you can find out many as you like. Multiples of any number, you get a triplet. Here also multiply by 2, 10, 24, 26. That's a multiple. So here you can multiply by 3, 4, 5 or you can divide by 2. This one when you divide by 2, you get 1.5, 2 and 2.5. That's also a triplet. So any multiple you get a triplet. But how can you find out this way? What's the pattern there? Observe carefully. 3 is there. 5. What do you think the next number is? 3, 5, 7. How can we find out the other two numbers? Look at carefully, there's a pattern. Here what I can do, take the number, square it. 3 squared, 9. Subtract 1, 8. Divide by 2, you get 4. And the next number is always here, adding 1 to that. Then the next number is 5. Look at the same thing here. 5 squared, 25. Subtract 1, 24. Divide by 2, you get 12. When you add 1, you get 12 and 30. Then what are these two numbers? 7 squared, 49. Subtract 1, 48. Divide by 2, 48 divided by 2, you get 24. So what's the next number? 25. So 7, 24, 25 also a Pythagorean triplet. So that's how we can find out Pythagorean triplets. This way you can take any multiple. This way what you do, square the first term, subtract 1, divide by 2. Now we'll see how we can find out the triplets. If you have given one value, 9 is given. You can take 3 out. When you take 3 out, this is 3. But we know if this is 3, 3 squared is 9, 9 minus 1, 8, 8 divided by 2, 4. 4 and 5 are the triplets. So what's the triplet now? You have to multiply by 3. So 3 times 3, you get 9. So what's the other two numbers? 12 and 15. Look at 12. I can take 4 out. Then if this is 3, what are the other two numbers, triplets? What are the triplets? 3 squared is 9, 9 minus 1, 8, 8 divided by 2, 4, 4 and 5. Then if it's 12, what are the other two numbers? 16 and 20. So here, remember that always try to keep the odd number inside. Then it's easy to, because you are subtracting one and find the other number. So here 3, 5, 7 all are odd numbers. So here keep the first number as odd number. 15, what's the number I can take? I can take 3 out and keep 5. Or I can take other way around as well, because both are odd numbers, 5 and keep 3. Now what are the other two triplets? If I take 5 here, 5 squared, 25. 25 minus 1 is 24. 24 divided by 2, you get 12. And the next number is 13. If you take 3, what are the triplets? 3 squared, 9. 9 minus 1, 8. 8 divided by 2, 4 and 5. Here, when you multiply by 3, you get 15, 36 and 39. Here another triplet you are getting 15, 3 times 4, 12, 5 times 5, 20, 25. So here when you take the different number out, you get different triplets. Now you know how to get all triplets. So make sure keep odd number here to use this method. Take example number 1. In the right angle triangle ABC, B is 90, AB is 5, BC is 12. Find the length of the side AC. So we'll sketch the diagram. A, B, C, AB 5, BC 12, and you are asked to find AC. And this is right angle, so you can use Pythagoras theorem. AC squared is equal to AB squared plus BC squared. Then substitute the values. 5 squared plus 12 squared. 5 squared 25, 12 squared 144. When you add, you get 169. Square root of 169 is plus 13. So the length of AZ is 13 centimeters. Example number 2. Find the length of CD based on the information given in the figure. So you are asked to find out this length. When you take that triangle, these two sides are unknown. So first you have to apply Pythagoras theorem for ABC triangle and then find BC. Then again apply for BCD triangle. So twice you have to use Pythagoras theorem. So what is BC squared? BC squared is 9 squared plus 12 squared. That's AC squared plus AB squared. 9 squared is 81. 12 squared is 144. When you add, you get 225. Square root of 225. We know that that's 15. Now apply the next one. For the next triangle, BCD triangle. So BCD triangle, what is CD squared? CD squared is BD squared minus BC squared. BD squared, we know that's 17 squared. Here BC squared, I can use 15 squared. Use difference between two squared terms. It's easy to, otherwise you need to know what is 17 squared, 15 squared. I'll do 17 plus 15, 17 minus 15. You get 32 into 2, 64. square root of 64, you get the length of CD. So CD equals square root of 64, that's 8. So this is in centimeters. So the CD length is 8 centimeters. Example 3, this is practical application. So you can use Pythagoras theorem in real life situations. One end of a wire is tied to a ring fastened at a point 1 meter below the top of a vertical utility pole. We'll take this the pole, this is the ground. So 1 meter below top of a vertical utility pole, while the other end is tied to a ring fastened on the ground. Here something like this. 8 meters away from the foot of the pole, here to here. So 8 meters away from the foot of the pole. The length of the wire between the two rings is 10 meters. So this is given 10 meters away. Find the height of the utility pole. Assume that the wire is stretched. So they are asking, find this length. First, I'll put x here and you have to add 1 to get the length of the pole. Ground and the pole, this is 90 degrees. So we can see this is a right angle triangle with lengths. You can use Pythagoras theorem. So what is x squared? X squared is 10 squared minus 8 squared. 10 squared is 100. 8 squared is 64. 100 minus 64, you get 36. When you take the square root, that's 6 centimeters. So this is 6. So what's the height of the pole? Height of the pole is 6 plus 1. 7 meters, because this is given in meters. Exercise 17.1. Fill in the blanks using the information in the figure. MO squared. This is hypotenuse. How can we write? MN squared plus NO squared. BD squared. BD is this one. We can take the ABD triangle. So what is BD squared? AB squared plus BD is this one. AB squared plus AD squared. Then AC squared plus CD squared. That's ACD triangle. That's AD squared. So what is AB squared? Look at these two. AD squared get cancelled out. You get AB squared is equal to, without that, what is AB squared? So what is AB squared? Now take this triangle, ABC triangle. So what's that? AC squared plus BC squared. Look at this one. PQ squared. Where's PQ? PQ, we can use this triangle. So PQ squared is PT squared plus TQ squared. QR squared. QR squared. This one. So this is also 90 degrees. So how can we write QR squared? I can write QT squared plus TR squared. This one, AB squared. AB squared, I can use the ABC triangle. AC squared plus BC squared. Then AE squared plus EC squared. AE squared plus EC squared is AC squared. Then AD squared. AD is this one. So that's to the ACD triangle. You can write AC squared plus CD squared. So you need to identify the triangle and then apply the Pythagoras theorem. Question number 2. Find the value of x in each of the right angle triangles given below. X is hypotenuse, so x squared is sum of squares of the other two sides. 36 plus 64, you get 100. Square root of 100, you get, that's 10 centimeters. Look at this one. It's a right angle triangle. You can straight away apply Pythagoras theorem. X squared is equal to 13 squared minus 12 squared. 13 squared is 169. 12 squared 144. When you subtract, you get 25. Square root of 25 is 5. Now, if you are not doing with square terms, how can we use difference between two square terms? I can do 13 plus 12 and 13 minus 12. So, what is 13 plus 12? 25 times 1. That's 25. So, sometimes it's easy to do that way. Part 3. X is here. First, we'll apply to this triangle and find out km squared. Km squared is root 5 squared minus root 2 squared. Root 5 into root 5, you get 5. Root 2 into root 2 is 2. 5 minus 2 is 3. So, km squared is 3. Then apply to KMN triangle. KMN triangle, you can apply Pythagoras theorem. X squared is equal to km squared plus 1 squared. Km squared is 3. 3 plus 1, 4. Square root of 4 is x. 2 centimeters. Square root of 4 I can take as 2. This one, x is here, but first we need to find out PR squared. First find PR squared, that's 4 squared plus 3 squared. 4 squared is 16, 3 squared 9. You get 25. Now use PQR triangle and apply Pythagoras theorem again. X squared is equal to 12 squared plus PR squared. PR squared we found, that's 25. 12 squared is 144 plus 25, you get 169. Square root of 169, you get 13 centimeters for x. Question number 3. In the equilateral triangle ABC, D is the foot of the perpendicular drawn from the vertex A. If the length of a side of a triangle is 2 centimeter, so all these 2 centimeters. So what happens when you draw a perpendicular line? This equally divide. 1 centimeter here and 1 centimeter here. Find the length of AD, express the answer as a third. Now we can apply Pythagoras to ABD triangle. We need AD squared. So what is AD squared? AD squared is equal to 2 squared minus 1 squared. 2 squared is 4, 1 squared is 1, 4 minus 1 is 3. So what's AD? Square root of 3. So square, it's a third value. We can write like this. Question number 4. The location Q is reached from the location P on the horizontal ground by traveling 15 meters to the north from P and then 8 meters to the east. So normally we take north up. So there's a position there, location P on the horizontal ground. So if this is the horizontal ground, P is here. The location Q is reached from the location P on the horizontal ground by traveling 15 meters north and 8 meters east. We know that north and east, that's perpendicular, 8 meters north. Draw the sketch based on the above information. So this is Q. Find the distance PQ. So this is right angle triangle, so we can use Pythagoras theorem. PQ squared is equal to 15 squared plus 8 squared. 15 squared plus 8 squared. 15 squared is 225 plus 64. You get 289. Square root of 289 is, what's the value? 17. 289 is 17. 17 times 17, you get 289. We'll see. So you get 289. So square root of 289 is 17 centimeters. So PQ length is 17. Not centimeters. What's the length? Meters, because it's given in meters. 17 meters. Question number 5. The lengths of the diagonals of a rhombus are 12 and 16. Rhombus means all sides are equal. The diagonals bisect each other at 90 degree as well. Diagonals bisect at 90 degree. So here I can write one is 12 and the other one is 16. So 12 means 6 and 6 here. 16 means 8 and 8. Find the length of each side of the rhombus. So rhombus, I'll take this one as x. This is a right angle triangle. I can use Pythagoras theorem. X squared is equal to 6 squared plus 8 squared. 6 squared is 36, 8 squared is 64. You get 100. Square root of 100 is 10 centimeters. So what's the length of one side? meters. So here 10. So what's the side of the rhombus? 10 meters. Question number 6. The figure illustrates the special creation Archimedes spiral. By considering the right angle triangles in the figure, find the lengths A, B, C, D, E, F, G. So here Archimedes spiral. So we have to start from here. So when you start from this side, how can we find out A? A squared is 1 squared plus 1 squared. 1 plus 1, you get 2. So what is A? Square root of 2. So that's the length of A. Then you have to start from here to get B. So that's why it's like a spiral. It's all connected. Starting from here, you can find all the lengths there. Then Pythagoras theorem for the other triangle. B squared is equal to A squared plus 1 squared. A squared, we found out that's 2. 2 plus 1, you get 3. B is square root of 3. Now take the next triangle. C squared is equal to B squared plus 1 squared. B squared is 3. 3 plus 1, you get 4. So what's C? Square root of 4. C equals 2. Now the next one. C squared. D squared is C squared plus 1 squared. C squared we found that's 4. 4 plus 1, that's 5. Square root of 5 is the D length. Again do. For the next triangle, here can you see we can find out all lengths starting from 1 root. 1 root, 2 root, 3 root, 4 root, 5 root, like that. We can find out using the Archimedes spiral. Then next triangle, E squared. D squared plus 1 squared. D squared is 5. 5 plus 1, 6. So E is root 6 centimeters. Then next one, E squared. So F squared is E squared plus 1 squared. E squared is 6. 6 plus 1, 7. So F is root 7. And the last one here, G squared is F squared plus 1 squared. You get 7 plus 1, 8. So G is square root of 8. Example number 1. ABCD is a square. Prove that AC squared is equal to 2AB squared. In a square, all sides are equal. So what can we write as AC squared? If you use ABC triangle, AC squared is equal to AB squared plus BC squared. So here AB squared, BC squared. So BC squared is same as AB. I can substitute AB squared plus AB squared again, because AB is same as BC. Then AB squared, I am getting 2AB squared. So AC squared is equal to 2AB squared. Example number 2. In the rhombus ABCD, diagonals AC and BD intersects at O. And also we know this is 90 degrees. Diagonals bisect at 90 degrees. Prove that AC squared plus BD squared is equal to 4AB squared. So we need to write down in terms of AB. Another important thing in rhombus, diagonals bisect. So here this length is equal to this length. This one is equal to this length. Now we can apply Pythagoras theorem for this triangle, AOB triangle. AOB triangle, what is AO squared? AO squared is AB squared minus OB squared. Now, what is AO? AO is half of AC. Half of AC. What's AB? We can write AB as it is. What is OB? OB is half of BD. You can write down why I can write this one. OA is equal to OC as well as BO is equal to OD. Now square this, you get AC squared over 4, AB squared, half into half again 1/4 BD squared. Now take this one to this side. I'm getting AC squared over 4 plus BD squared over 4 is AB squared. So same denominator I can write as AC squared plus BD squared divide by 4 is AB squared. Then multiply this by 4. You get AC squared plus BD squared is equal to 4 AB squared. Example number 3. In the triangle ABC, BAC angle. BAC angle is an obtuse angle. AX is drawn from A perpendicular to BC. Prove that AB squared minus AC squared is equal to BX squared minus CX squared. So we'll first find out AB squared. What is AB squared? AB squared is BX squared plus XA squared. What is AC squared? AC squared is AX squared plus XC squared. Now I want to subtract these two. 1 minus 2, you get AB squared minus AC squared is equal to BX squared plus XA or AX, same thing. I'll write XA here minus, so I'm subtracting, so this becomes minus as well. So XA and plus A and minus get cancelled out. You are getting BX squared minus CX or XC, same. So I'll write CX because it's given as CX squared. Exercise 17.2. AD is perpendicular to BC. In the triangle ABC, see figure, if AD equals DC, this length is equal to this length, prove that AB squared is equal to BD squared plus DC squared. So we'll first take ABD triangle. What's AB squared? AB squared is equal to BD squared plus AD squared. Then I can write AD squared as this one, using this one. AD squared is same as CD squared. Because AD is equal to DC. So here what happens? BD squared, CD, DC, same thing. I'll write DC squared. So AB squared is equal to DC squared. AB squared is equal to BD squared plus DC squared. Question number 2. AD is a perpendicular to BC in the triangle ABC. ABC. AD is a perpendicular to BC. Prove that AB squared plus CD squared is equal to AC squared plus BD squared. So we'll take AB squared first. ABD triangle. AB squared is equal to AD squared plus BD squared. Then what is AD squared? According to the other triangle, ADC triangle, AD squared is equal to AC squared minus CD squared. Now I want to plug this one here. So AB squared, AD squared is AC squared minus CD squared plus BD squared. Then what happens? I can take CD to this side. I'm getting AB squared plus CD squared is equal to AC squared plus BD squared. Question number 3. AD is perpendicular to BC. This is an equilateral triangle ABC and AD is perpendicular to BC. Prove that 4AD squared is equal to 3BC squared. So all sides are equal. This is also equal. So we'll first write down AD squared. What is AD squared using ABD triangle? AD squared is AB squared minus BD squared. Here I can use AB is same as BC. So AB is same as BC. So I can plug instead of AB, this is BC squared. What is BD? We know that this is an equilateral triangle. When you draw a perpendicular line, this length is equal to this length. So how can I write BD? Half of BC. Now I'm getting BC squared minus half into half, you get 1/4 BC squared. So this one I'm getting 4/4 BC squared minus 1/4 BC squared. When you subtract, you get 4 minus 1, 3/4 BC squared is AD squared. Multiplied by 4, you get 4AD squared is equal to 3BC squared. Question number 4. AD is perpendicular to BC. It's marked in the equilateral triangle ABC. Again, equilateral triangle. So this length is equal to this length. BC has been produced to E such that DC is equal to CE. So this length also equal. Prove that AE squared is 7EC squared. 7 of that. So we'll start from AE squared. We'll take ADE triangle. What is AE squared? AE squared is AD squared plus DE squared. What is DE? I can write DC plus CE, or I can write this is double of CE because these two lengths are equal. Instead of this one, I can write DE is twice of EC. I'll use the same side, otherwise it's complicating. EC squared, 2EC whole thing squared instead of DE. So what's the value? AD squared plus 4EC squared. That's AE squared. Now I need to get rid of this AD squared. So I'm taking ABD triangle. When I take AB triangle, what is AD squared? AD squared is equal to AB squared minus BD squared. So AB squared, how can I write? AB squared is BE squared. BC squared, because AB and BC, these two lengths are equal. That's an equilateral triangle. Instead of AB, I can write BC squared. BD. BD I can write here. BD length is same as CE. CE squared. So BD equals CE. Then what is BC? BC length I can write twice of CE or EC. So instead of BC I can write 2EC squared minus CE squared or EC squared. 2 times 2, 4. 4EC squared minus EC squared. You get 4 minus 1, 3EC squared. Now I can plug it here. So I'll take this one as first one. I'll take the first equation. AE squared is equal to, instead of AD squared, I can use 3EC squared plus 4EC squared. So 4 and 3, you get 7EC squared. So you get AE squared is equal to 7EC squared. Question number 5. The diagonals of the quadrilateral ABCD bisect each other perpendicularly at O. The diagonals of the quadrilateral ABCD, we'll take any quadrilateral ABCD. Diagonals bisect each other means this is 90 degrees at O. Prove that AB squared plus CD squared is equal to AD squared plus BC squared. So when I take AOB triangle, I can write down AB squared is equal to AO squared plus OB squared. Then I need CD squared. CD is in this triangle. OCD triangle. What is CD squared? OD squared plus OC squared. I'll add these two, 1 and 2, 1 plus 2. I am getting AB squared plus CD squared, these two, and I am getting AO squared plus OB squared plus OD squared plus OC squared. Now look at carefully. AO plus OC. This squared plus this squared, we get AC squared. I'll take these two together and these two together. AO squared plus OD squared. OB squared plus OC squared. Now look at the diagram and see. AO squared plus OD squared. Now it's the right angle triangle here. I can write instead of this one as AD squared. What's OB squared and OC squared? I can write this one as BC squared. So that's what we need. AB squared plus CD squared is equal to AD squared plus BC squared. Question number 6. O is a point within the rectangle ABCD. It's a rectangle now. So O is within the rectangle. Inside, prove that AO squared plus CO squared plus is equal to BO squared plus DO squared. Hint. Draw a parallel line through O to any side of ABCD. So we'll take any point O. Draw a parallel line to any side of ABCD. So here I can draw parallel line to this one, and I can connect these points. I know this is a rectangle. These are 90 degrees. So this is 90 degrees. Now we need to find out AO squared. AO squared, CO squared, all these lengths. So we'll do that. I'll take this one as X and Y. What is AO squared? If I take this triangle, what is AO squared? I can write AX squared plus OX squared. Then what is CO squared? CO squared, I can use this triangle. CO squared is OY squared plus CY squared. Now I'll take this one as 1 and this one as 2. And also I drew a parallel line to this one. So this length is equal to this length, and this length is equal to this length because it's a parallel line. So I can add these two, 1 and 2. I'm getting AO squared plus CO squared is equal to AX squared plus OX squared plus OY squared plus CY squared. Now, what is AX? I can write instead of AX, BY. So BY squared and what is OY squared? I'll add together, and instead of CY, I can take dx. We'll see whether we want that BY plus OY squared, CY squared plus OY squared. I am getting OC squared. So I need OD squared. So I need to put, instead of CY, that's DX. DX squared. Now see, these two, BY squared plus OY squared. What's this? OB squared. These two, OX squared plus DX squared, you get OD squared. So we want this side. Okay. Now we have to write down why we equate this. CY is equal to DX and AX we took as BY. So when you add, you are getting AO squared plus CO squared is equal to OB or BO, same thing, BO squared plus OD or DO, same thing, DO squared. Question number 7. P is a point within triangle ABC. The perpendiculars drawn from the point P to the side BC, AC and AB meet the sides DEF respectively. Prove that. First one, BP squared minus PC squared. Here we need to connect. BD squared minus DC squared. So I connected this BP and PC line. So we'll take what is BP squared. BP squared is, I can write BD squared plus PD squared. Then what is PC squared? From this triangle, PC squared is PD squared plus DC squared. This is the first one, and the second one I can subtract 1 and 2. So I am getting BP squared minus PC squared is BD squared plus PD squared minus PD squared and minus DC squared, because I subtracted the second one. Now can you see PD squared get cancelled out? So I get BD squared minus DC squared is equal to this one. That's the first part. Second part. Second part, BD squared plus C squared plus AF squared is equal to CD squared plus AE squared plus BF squared. So we'll take separately BD squared. BD, this one. BD squared is BP squared minus PD squared. That's first equation. Then CE squared. CE is this one. So how can I write? PC squared minus PE squared. That's my second equation. What's the next one? AF squared. AF squared is this one. I'll connect this one with this one. Then AF squared I can write AP squared minus PF squared. That's my third equation. Now left hand side is all addition, so I'm adding 1 plus 2 plus 3. And we'll see what happens. I'm getting BD squared plus CE squared plus AF squared. That's the left hand side of the equation. Now look at carefully and see how we can Add these two. Now we'll take PD. PD is this one. PD, and which side we can connect? PD with either BP. BP is not BP we took, so we can take the other side. PC squared. These two. What happens? PC squared minus PD squared, I am getting CD squared. Now we'll take another one. This one, PE squared. PE squared is this one. So I can connect with AP. AP squared and PE squared, these two. What happens? AP squared minus PE squared. I am getting AE squared. And the other one, I'll take red color. What about these two? BP and PF. These two. I am getting BF squared. So I am getting CD squared, AE squared and BF squared. Question number 8. The two squares ABXY and BCPQ lie on the same side of the straight line ABC. ABC is just one line. ABXY is a square. And BCPQ is also another square. BCPQ, another square. Lie on the same side of the straight line ABC. Prove that PX squared. I need to connect this. Px squared is plus cy squared. Cy squared is equal to 3 times AB squared plus BC squared. So we know these angles are right angles. And this is also right angle. So we'll try to find out Px squared first. Px squared. What can I write Px squared? I can write Qx squared plus PQ squared. Now PQ is not there. So I can write instead of PQ, that's BC squared. Because PQ is equal to BC. Then Qx squared I'll keep as it is. Then next one is Cy squared. Cy squared I can write AY squared plus AC squared. What is AY? AY is not there. AY is same as AB. So AY is same as AB. So I can write AB squared plus AC squared. AC squared, how can I write? I can write AC as AB plus BC. What is QX? If I can write in terms of this length, it's easy. So I can write QX as QB, BQ minus BX. BQ minus BX, but I know BQ is same as BC. BX is same as AB. So I'm writing in terms of BC and AB. So QX is this. So I'm taking the first one and substitute. Take the first one. Px squared is equal to, instead of Qx squared, I can write BC minus AB whole thing squared plus BC squared. I'll simplify this. Take the square term, BC squared. Middle term is minus 2 times BC AB plus AB squared and BC squared here. So simplify. I am getting BC squared 2 BC squared minus 2AB BC and AB squared. That's my, I'll put A equation. Now take the second equation. Also I need to simplify. Take the second one. We'll simplify. CY squared is equal to AB squared plus, expand brackets, I'm getting AB squared plus 2AB BC plus BC squared. So when I simplify, I'm getting 2AB squared, these two, plus BC squared plus 2AB BC. Let's take, this is B equation. Now we need to add the two. A plus B equation. What happens? A plus B. I am getting Px squared plus Cy squared. That's what we need in the left hand side. Then 2BC squared and BC squared. I'm getting 3BC squared. AB squared and this 2AB, I'm getting 3AB squared. Minus 2AB BC plus 2AB BC get cancelled out. So I can take 3 out from this and write down BC squared plus AB squared is equal to Px squared plus Cy squared. So that's what we need. 3 times AB squared plus BC squared. So 3 times AB squared plus BC squared. Exercise 17.3. The following triplets or triples are the lengths of the sides of two triangles. Select the triangle which is a right angle triangle and write down the corresponding Pythagorean triple. So how can we do that? We know longer side squared is the sum of the other square terms. We'll square it and see. 8 squared, 64. 15 squared, 225. 17 squared, 289. Now add and see. These two, when you add, what you get? Because longer side is 17. When you add 64 and 225, you get 289. So we can see 8 squared plus 15 squared is equal to 17 squared. So if this one satisfy means this is a right angle triangle. So we can write this is right angle triangle. This one. Largest side is 25. Normally the hypotenuse is the longest side. So 25 squared is 625. What is 14 squared? 14 squared? 196. We'll check. 14 times 14. 196. Then 18 squared. 18 times 18, 10 times 8, you get 324. When you add these two, what you get? 6 plus 4, 10, 1 is remaining, 10, 2, 12, 1 remaining, 5. So in this case, 625 and 520 is not equal. So we can see that it's not a right angle triangle. Question number 2. Based on the measurements given in figure 1 and 2, show that BAC is a right angle in each figure. BAC. So this one we have to show that it's a right angle. And here also BAC. This one you have to show that it's a right angle triangle. So first we need to take this triangle and find out AB squared, because that's a right angle triangle. What's AB squared? 12 squared plus 9 squared. 12 squared is 144. 9 squared is 81. You get 225. Square root of 225 is 15. So we got AB as 15. Now we'll see the largest side is 17. So 17 squared we found out 289. 8 squared 64 and AB squared is 225. When you add these two, what you get? 982. So 17 squared is equal to 8 squared plus 15 squared. So therefore BAC angle is 90 degrees. This one we don't know this length and this length. So we have to use Pythagoras twice because this is 90. So what is BD squared? BD squared is 10 squared minus 6 squared. 100 minus 36, you get 64. BD equals square root of 64, that's 8. When you look at the other triangle, what is DC? DC squared is 7.5 squared minus 6 squared. How you find out 7.5 times 7.5 at once? I taught this method before. 75 times 75. We do 5 times 5, 25. 7 times 8, 56. 5,625 is for 75 times 75. Is it 7.5? Then you have to keep 2 decimal places. 56.25. If it's 4.5 squared, what you do? 45 times 45 and then put 2 decimal places. 5 times 5, 25. 4 with the next number. 4 times 5, 20. So 20, 25. So 7.5 squared is 56.25. 6 times 6 is 36. When you subtract 36, what you get? 20.25. What's 20.25? 4.5. Square root of reverse 1 is 4.5. So DC is 4.5. Again, if you have given a decimal number, this decimal number, how you find out the square root? Take 20, 25. We need square root of this. So 25 square root is 5. So you get 0.5 there. Then square root of 20. What's the closest value? 25 is, square root of 25 is 5. So 20 is 4 and 5. You have to find out two numbers, two consecutive numbers that you get 20. 4 and 5. So the lowest number we take. Lowest number of 4 and 5 is 4. So square root of 20.25 is 4.5. So DC is 4.5. Then what is BC? BC is BD plus DC. BD is 8. DC is 4.5. So what's that? You get 12.5. Now we'll look at the big triangle ABC and C, whether it works. We'll take ABC triangle. What is BC squared? 12.5 squared. What's the easy method? 125 times 125. 5 times 5, 25. Here, 12 times 13. The next number, 12 times 13. So you just add 156. So you get 156 there. So you need to keep 2 decimal places. 156.25. That's 12.5 squared. Then AB squared is 10 squared. That's 100. What is AC squared? AC squared is 7.5 squared. Again, what is 7.5 times 7.5? 5 times 5, 25. Then 7 times 8, you get 56. So 56.25. Then we'll see when we add these two, whether we are getting this number. So these two, when you add, what you get? 156.25, you are getting 156.25. So this one is same as this one. So therefore, we can see that BAC is a right angle because it satisfies the sum of these two terms to the hypotenuse square. Question number 3. By completing the table given below, find the Pythagorean triples corresponding to the given pairs of values. Verify your answers. This is another method. I explained you how to get the triplets or triples. So this is another way of finding Pythagorean triples. So they have taken two numbers x and y and then square it. 2 squared you get 4. Y squared 1. Then take the difference between these two, that's a. 4 minus 1, 3. Then double of xy. These two, double of xy. 2 times 1, 2. 2 times 2, 4. Then add these two. X squared plus y squared, you get c. 4 plus 1, 5. So what are the three triples? 3, 4, 5. This one, 5 and 4. 5 squared you get 25. 4 squared, 16. 25 minus 16, you get 9. 2 times xy. 5 times 4, 20. 20 times 2, 40. Then x squared plus y squared. 5 plus 16, you get 41. So what are the triplets or triples? 9, 40 and 41. Now do the next one, 4 and 3. X squared, 4 squared is 16, 3 squared is 9. Difference between these two, you get 7. Double of these two, 4 times 3, 12. 12 times 2, 24. Add these two, you get 25. So what are the triples there? 7, 24, 25. This one, 6 and 5. 6 squared, 36. 5 squared, 25. Now take the difference. When you subtract, you get 11. Then double of these two, 6 times 5, 30. 30 times 2, 60. Then add these two, you are getting 61. So what are the triples? 11, 60, 61. Next one, 7 and 5. 7 squared is 49. 5 squared is 25. Take the difference. Difference is 24. Double of these two, 7 times 5, 35. 5 times 2, 70. So when you add these two, you are getting 74. So what are the triples? 24, 70, 74. Miscellaneous exercise. First one, the chord AB of the circle with center O, which lies at a distance of 9 cm from O, is of length 24 centimeters. Find the radius of the circle. So we'll draw the diagram. There's a circle with center O. The chord AB. So we'll draw chord AB somewhere there, which lies at a distance of 9 cm from O. That means 9 cm from O, the perpendicular length. And the length of the chord is 24. That means 12 and 12. We know it's bisecting. Find the radius of the circle. So radius, if we take this one as R, you can use Pythagoras theorem because this is a right angle triangle. So R squared is equal to 9 squared plus 12 squared. 9 squared 81, 12 squared 144. When you add, you get 225. When you take the square root of 225, we get 15 centimeter for the radius. Question number 2. Construct the triangle ABC, where AB is 2, BC 3 and B is a right angle. 2 is 2, BC 3 and B is 3. 2 is 2, BC 3 and B is 3. 2 is 2, BC 3 and B is 3. 2 is 2, BC 3 and B is 3. 2 is 2, BC 3 and B is 3. 2 is 2, BC 3 and B is 3. 2 is 2, BC 3 and B is 3. 2 is 2, BC 3 and B is 3. 2 is 2, BC 3 and B is 3. 2 is 2, BC 3 and B is 3. 2 is 2, BC 3 and B is 3. 2 is 2, BC 3 and B is 3. 2 is 2, BC 3 and B is 3. 2 is 2, BC 3 and B is 3. 2 is 2, BC 3 and B is 3. 2 is 2, BC 3 and B is 3. 2 is 2, BC 3 and B is 3. 2 is 2, BC 3 and B is 3. 2 is 2, BC 3 and B is 3. 2 is 2, BC 3 and B is 3. 2 is 2 Using the triangle you constructed, find the value of root 30. Okay, so we'll draw the triangle. B angle is 90. ABC, AB is 2, BC is 3. Find the value of root 30. So we'll see what is AC squared. Here this is construction, so we need to construct the diagram. But when you use the Pythagoras theorem, just check what is AC squared. 2 squared plus 3 squared. 2 squared is 4, 3 squared is 9. 9 plus 4, 13. So if you can find out the length of AC, it's root 30. Now we'll construct the diagram and see what's the AC length. So we need a ruler. And we'll take the compass to construct the line. So here, so first draw a line and take the point as B. BC length is 3 centimeters. So we'll take 3 centimeters from here. Mark the point C. Take the compass. Measure 3 centimeter length. Keep on top of this and mark the point C. That's C point. Then 2 centimeters we need. Take the compass again and measure 2 centimeters. And we need to draw an arc somewhere up. Now we need to draw a perpendicular line. So we'll take the compass and try to draw the perpendicular line to B. Just take any length, draw an arc, take the other side and draw an arc. Then we'll take the point here, take a longer distance and keep on top of this point. Draw an arc here and keep on top of this point and draw the other arc. So the intersecting point and this one we can connect. And here this point is 2 centimeter away. This and this you get AC. Now we'll measure and see AC length with the compass and see what's the length. So this is roughly this much. So you keep the compass on top of the ruler and measure the length. You get 3.6 centimeters. So correct to 1 decimal place. This is 3.6 centimeters. Question number 3. Construct straight line segments of the lengths given below. So this is like Archimedes spiral. So root 8 we need to find out. So root 8, how can we get root 8? So here we don't need to measure the length, so you don't need to draw it accurately. So 8, root 8, how can we get 8? If we can get 2 and 2, what's that? You get this side, it says ABC triangle. What is AC squared? 2 squared plus 2 squared. 2 squared is 4, 4 plus 4, you get 8. So if this is AC, this is root 8. So that's how you can get root 8. So you need to take a right angle triangle with 2 and 2. 10. How can we get 10? How can we get 10? 3 and 1. 3 squared 9, 1 squared 1, 3 plus 9 plus 1, 10. So we can get, if this is ABC triangle, AC squared is 3 squared plus 1 squared. 3 squared is 9, 9 plus 1, you get 10. So AC is square root of 10. 41. How can we get 41? So 5 squared, that's 25. 41 minus 25, you get 16. So that means 4. So 5 squared. So we'll take ABC triangle. So AC squared is equal to 4 squared plus 5 squared. 4 squared is 16 plus 25. You get 41. So AC is the value for square root 41. Question number 4. ABC is an equilateral triangle. D is the midpoint of AB. E is the midpoint of CD. Prove that 16 AE squared and 7 AB squared. We know when you draw the perpendicular here, the midpoint and this one, it's perpendicular. So this is 90 degrees. Now we'll use the Pythagoras theorem for this triangle. What is AE squared? AD squared plus DE squared. Now we need AB. AB is same as BC or AC. So what is AD? AD is half AB. DE? DE is half of CD. So when you simplify, you get AB squared over 4 plus 1/4 of CD squared. So what is CD squared? Using the other side, so this is 90 degrees. I can write CD squared is BC squared minus BD squared. But I know that BC squared BC is same as AB. So I can write instead of BC squared, that's AB squared. BD squared. BD, how can I write? That's half of AB. I can write down half of AB squared. Now we'll simplify. I'm getting AB squared over 4 plus 1/4 of AB squared here minus half into half, 1/4 of AB square. Now simplify inside first. This is AB squared over 4 plus 1/4. Inside this is 4AB squared over 4. 4 minus 1, 3AB squared over 4. Now simplify. I'm getting AB squared over 4 plus 3 over 16 AB squared. Now the common denominator is 16, lowest common multiple. So that means I have to multiply this by 4. 4 times this, 4AB squared plus 3AB squared. I get 7AB squared over 16. Cross multiply. What's this? This is AE squared. When you cross multiply, I get the answer 16. AE squared is equal to 7 AB squared. Question number 5. In the triangle ABC, B is an acute angle. The foot of the perpendicular drop from A to BC is x. Prove that AC squared is equal to AB squared plus BC squared minus 2BC BX. So this is done only for acute angle. You can do this for obtuse angle as well. Then this becomes plus. So we call it Apollonius theorem. So you will get this in combined maths A-level class. So we'll look at this one. AC squared. How can I write AC squared? I can write AX squared plus XC squared. I want to connect BC instead of XC. How can I write XC? XC is BC minus BX. Open brackets, AX squared plus BC squared. Middle term is minus 2BC BX plus BX squared. Now, what is AX squared? I am taking this one here, AX squared plus BX squared. And then BC squared minus 2BC BX. Now, what can I write? For this one, AX squared plus BX squared, that's AB squared. So, I am getting AB squared plus BC squared minus 2BC BX. So, this is done only for acute angle. If this is obtuse angle, so you get something like this. So, instead of minus, you will get plus 2 times BC BX if this point is x. So, you can try that also. We did this for only acute angles. In this lesson, we covered how to use Pythagoras theorem in real life application and Pythagorean triples. So, remember how to get Pythagorean triplets or triples and apply Pythagoras theorem in real life applications.